Hello everyone, and today we're going to go through the basic development workflow that at least my group will be using in CPRE 431 for our security project on the Plan 9 kernel fuzzer. This is a transitive video, so the material covered inside should be useful for anyone trying to get into a C or Go programming workflow on Plan 9 and specifically 9front in this case. However, some parts might not be useful, such as how I have the file system be exported and how I have Drawterm running, a Drawterm listener running from the terminal without authentication. This is not really recommended and is only really relevant for the host-only adapter use in VirtualBox, which lets us develop from Unix a bit easier, which I think will ease the transition for people looking to come from a Unix development background and moving into a Plan 9 or 9front development workflow. So the first few things we're going to cover is the interface. This is the screen you'll probably be greeted with in most 9front installs, including the CPRE 431 virtual machine releases. You get a basic text window. Plan 9 uses all the mouse buttons. If you're using your typical Microsoft mouse, you'll have a mouse button. The middle mouse button will be on your scroll wheel probably. I have a Logitech wireless mouse right here, and there's just a button inset behind the scroll wheel since there's locks and unlocks. You can also use modifiers such as shift on the right mouse button to get you to a middle click menu if you really don't have one. And if you have a middle click and you don't have a right click for some reason, shift on middle click will give you the right click menu. The window manager is a superset of Rio called gRio. It's written by Mycroft. If you hit exit, it'll exit you out of it. It has a few other oddball features such as new Acme, and this is one of the editors that we'll be covering. The mouse is used very heavily, so I recommend you get one if you're on a laptop. ThinkPads or anything with a track point like system is recommended, since it lets you get access to all the buttons fairly easily without moving your hands too much. So the first few things to cover are the editors. I haven't added anything extra except for the Vim port, which is installed through the ports package manager, which I have in /sys/ports. There's a bunch of stuff here, but what really matters is that we have Vim, not that it's really recommended. We can draw a new window using the right click menu. If we want, we can run VT to give us a virtual terminal, not that it really matters with the Vim port. Except we can't because it uses the mouse. So we're just going to run Vim. And we see we have what resembles a Vim interface. It doesn't work quite how you might expect in some cases, and it doesn't have all the features. It's a fairly old port, but in general, Vim exists. Not that it's recommended. So you can use it. The native Plan 9 editors are Sam, Acme, and Ed. Ed being the standard Unix editor. Ed's pretty easy to use. It's the line-based editor. Sam has a regex-based language in it that is similar to the Ed language, but extended in a few ways. And Sam has a non-graphical interface through sam-d, which behaves a lot like Ed, though it's a little more verbose rather than Ed, which just gives you question marks. Sam has a graphical component, which is really how it's meant to be used. We get greeted with this fairly cryptic interface. We get our different right-click menu. Sam has its own windowing built in, so you can make this nice and big if you want. You'll get marginal gains on as small as a screen as the VirtualBox allows, though you can add other Visa modes if you want, and there is a script called setRes that lets you set the resolution of the terminal, including get all the ones currently available. But Sam works in a pretty intuitive manner, so if we wanted to, for example, edit a C source file, let's go into repos, and let's clone a repo real quick. The Git technically exists through ports. I don't think it's installed on the VM. Yeah, it's not. It's technically dgit by deruzin from GitHub. It's in /sys/ports somewhere. but it's not really recommended unless you really need it, since there's a few features missing. So the main one we have is Mercurial. There's a lot of options here. Mercurial is a pretty good package manager. It's a fairly old version that we're running, but we can use it to clone, for example. We see over here I have a few tabs open, including the 9front FQA. This is probably the best source for information you got. I'm going to clone this repository real quick. It's on Bitbucket. I'm just going to type it in here since I don't have connector on my clipboard. You do that. It's a lot like Git in this manner. The main difference you'll see if you're just doing clone, pull, push stuff is you need to update after a new pull rather than getting merges right away. And when you add a file, it's tracked forever until you stop tracking it. So every time you commit, you don't have to re-add the files you want to commit. It'll just look for all the changed files that are already added. So we see a bunch of stuff in here. Let's go to some C source. This will be more fun. We're going to SAM. Let's look at rot. Let's look at smiley.c. I like this one a lot. This is a classic that I believe was written by Ken Thompson. I think there's a quote about it on Google Plus somewhere from Rob Pike or Russ Cox. I don't really remember who. But this is a cute little program. It's a little weird to see with the current font I have, which we could change if we wanted to. We're not going to bother right now. It does some shenanigans using Unicode. It's mostly to show off the use of Unicode in 9 and how it's available in Plan 9C dialects, which are slightly different. This is nicely documented in this document on CatV called C Programming in Plan 9 from Bell Labs. It's a pretty good read. There's a PDF version available for download. And it goes over the main differences between Plan 9C and ANSI C89. There's a few C99-like features hiding out in here, but for the most part, you can use it a lot like I use C89. So in SAM, for example, we have our little window here. The right-click menu gives us windowing options. The middle-click window gives us editing options. SAM maintains its own editing buffer from the rest of the system. So if we came over here, we echo ducks. We highlight ducks. And then from the middle-click menu, we snarf, which you can think of a lot like copy, though it is a distinct operation. We can then come down here, we can paste it. We see ducks. However, if we went in SAM, we came down here, we did paste, nothing happens. There's this Rio option here, and it takes, I believe, the most recent thing. So if you copy something in Rio, more recently you've copied something in SAM, it'll import from Rio or vice versa. So we can do this, and then if we paste, we get ducks. So that's pretty handy. It goes both ways too. We could do it back out to Rio if we wanted. But we can use the regular expression language to our advantage. If we wanted to replace every smiley, for example, in our selection, we do /, and we press Alt, and then colon closing parentheses, and that gets us a smiley face, which is nice and handy. It's a alt code system that's fairly intuitive. It's documented in /lib/keyboard. So we cat that in here, and it shows us the alt combination to type it. So like smiley is right here, for example. And we could get this line if we wanted to. If we wanted to know how to type a specific character we see. And you can see that we just type this. Frowny face is the inverse, of course. Though I can't actually type it because it's not in my font. We're not going to worry about it too much. But we can replace all the smileys in this selection. Come up to the command window, and let's replace them just with capital X, so it's easy to see. And we see all of those have been changed. There's an undo command. It changes them back. This is pretty much how most of SAM works, is using regular expressions on selections, and to understand the regular expression, you should use the manual page. Manuals are accessed through man, which is the same way they're accessed in Unix-based systems in general. So we have a man command, and we can do man 1SAM, and this gives us the section 1 manual for SAM. We can page through this if we want. We see all the options, and there's some discussions about addresses, how the regular expressions work, compound addresses, commands, things like that. This gives you a comprehensive summary, more or less. You can see there's ones for ed, this one's for Rio, which is the default windowing system. There's a regular expression manual. There's also a -p option if you want to render to a PDF, so we can do 6 regexp. It renders us a nice PDF of the manual page. And we can use mouse click menus to page through them. There's nowhere to page for this one, but I think this is a nice typeset version anyways. So this is nice, and this is a good way of getting around. If we wanted to look to see any manuals that reference SAM, we can use lookman. This gives us every manual page that has an occurrence of SAM in it. Could lookman, God, that's all I mentioned in scat. So that's nice and handy. Manual pages are probably the best way to getting around. The only real exception is /sys/doc, which has some papers in it, and you can use the pager or the reader program page to read these files. And you see PostScript and a few other formats in here. You can also read PDFs and render image files. So we can, for example, pull up the ACID paper. Oh, I believe we have to do this. Yeah, there we go. And that runs it through Trough. But we can see the ACID paper just fine. We can page through this one. This one's a lot longer. So we can see like direct page number. We can go to next. We go to original size. We can fit height. It's pretty handy. Works great over a remote connection. Over Drawterm, for example, when you can get a bigger monitor on a native terminal with a bigger screen. And we can just quit with Q and just trash our changes. The other big editor of choice is Acme. Acme is what I usually use, and we're going to do some playing with Rot13 real quick. We'll see we get what looks like its own self-contained windowing system, because it is. And Acme is unique because you can click on text, which is a pretty unique concept. And we have this nice little command called win. You can type it, and it gives us a little shell window, which is nice. And if we right-click on a file in here, for example, it opens it for us. And if we have a header up here and we right-click on it, it also opens it for us, which is great for finding references to stuff. We can do the same thing with text. It'll cycle through the file to find us the next usage of something, for example. And it just jumps the cursor to it. There's a few other oddball things you can do. The coolest one by far, other than this nice little column and window-based system, you can drag windows between columns. Come over here, for example. Is if you build a program, and in this case, this is a C program, and most C programs distributed for Plan 9 will have a makefile of some sort, or be built by a makefile rather than by hand. But if you must build by hand, like we will in this case, you need to know your architecture, and you need to know what compiler is for your architecture. An easy way to find out is, of course, to read the manual page. The manual for this is 2C. 2C is the title for the compiler suite. And we'll see it says the C compilers. This is also described to some length in C Programming and Plan 9 from Bell Labs, which I highly recommend reading for a little bit more context. We see 8C is the Intel i386 and Pentium family compiler, and 6C is the 64-bit AMD 64 incompatibles compiler. ARM is 5C. And there's a handful of other ones hiding out in here, which is nice and handy. So, armed with the knowledge that we are on a, let's check our CPU type, 64-bit system, AMD 64. We choose that compiler, which is 6C. And its companion, the linker, which we can get from the 2L manual page secretly. They follow the same convention, so it's really just 6L. But that's the manual for the loaders. And there's an assembler, of course, and all that good stuff. So, armed with this knowledge, we know that on a 64-bit system, if we want to build a 64-bit binary, we're going to use 6C. So we're going to do 6C rot13.c. Okay, what's changed? List column rather than ls, which just lists vertically. we see we now have a rot13.6. I'm going to try to open this because it's a symbol file. It's a lot what you get on a Unix-based system. If you use GCC, for example, you gcc-a, and you get a .out file. This is the same idea, except instead of .out, which is kind of ambiguous, you get .6, which tells you this is a symbol file for an AMD 64 system. So we're going to link it. Do rot13.6 using 6L. What's different? We have 6.out, much like a.out, except a.out's ambiguous. Run a.out. And rot13's it, kind of. This is a pretty bad program, but you get the general idea. Let's introduce a bug to this and show off a nice little feature of Acme here. Let's get rid of 6.out and rot13.6 real quick. Let's introduce a bug. Something that gives us a compile time error, for example, commenting out, and I should do it. I have to catch myself there. MK is the typical build system, and for example, we go into fuzz C, we'll see there's a make file in here. And we make it, and we see it calls 6C for us, it calls 6L for us. If we look, we get a 6.out, which doesn't really do anything at the moment. And we can make clean, a lot like regular make, except they're two very different programs, and they have slightly different syntax and slightly different capabilities. But all that aside, come over here, introduce our bug. You'll notice that when I change it, this turns dark blue, and we get the option put rights. There's no keyboard shortcut for it. So we're going to do the same thing. rot13.c. Oh, and we get an error. We still get a file? Nope, we don't get a symbol file. So we need to deal with this somehow. We see that it gives us rot13.c and a colon, and then the line number. It turns out we can just right click on this. Actually opens a new window because of how paths work. It doesn't really matter though. And actually jumps us to the line. We just right click and it just opens up for us. Similarly, if this was a multi-file project, it would jump us to the file and the line in that file if we didn't have it open, and open it in a new window. But this is pretty handy. We know the I is missing. We see that the first instance that the compiler realizes it's missing is here. And of course we just never declared I, so we can do that, and we can do and of course we get our 6.out, and the program kind of works, but it's pretty fun. I'll just get rid of 6.out and rot13.6. Cool. So that basically covers how most of a development routine works. There's of course plenty of things we could go into beyond that for using the editors. We're mostly trying to cover what exists rather than how to use it at any depth. So that was handy. The VMs also come with Go, the Go version. We'll see it's 1.11. We can get the help output. This will work. We could, for example, make a quick little Go program. And let's do this in Acme. Okay, we're going to go over here, make a new win, come over here, package main, import func name, and we can just do something nice like, I don't know, format.println hello world, and a smiley face. There we go. Put that to write it, and do go run test.go. Give it a second. It's extra slow because we're in VirtualBox. This has to go and make the virtual build and all that. Oh, and there we go. We get hello world. Cool. So that's convenient. Just exit out of that. Of course, we just cat it. We see that our file's still there. So that's nice. So going past this, we have a few things that are specific to the CPRE 431 VM. So if you're just looking to get into the gist of things on 9, this is kind of where the relevance ends, though the scripts may be of interest. So in our home folder, we have a bin folder. Inside the bin folder are folders for each architecture where binaries can go in, though there's not anything there right now. You'll notice that slash has a similar convention, so there's like slash AMD64 slash bin. This is where platform-specific binaries go. But we're in our home folder, and RC is where RC scripts go, RC being plan 9 shell. I don't even think we set shell. Yeah, certainly not. There's no other real alternatives. There's 8/PSH, but it kind of sucks, and it's really only there as a nicety. We have dlisten, for example, which is a script I have on postnix, and sharefs is also on postnix, so they've been slightly modified here. Sharefs is pretty straightforward. It shares the file system on the default 9p port, 9p file server port of 564, and exports /root. Since slash is a virtual folder in plan 9, /root is really where all of your disk files are. So it's nicer to export /root since there's less virtual stuff going on. In fact, there's really no virtual stuff going on. But that's nice, and that lets us mount this without any real argument complexity from a remote system. Dlisten is also nice. In this case, it sets passwordless Drawterm authentication on a terminal. Since terminals can't run their own authentication server and file system server, and these are separate concepts in Plan 9, we could run them, but we're not going to. We're not going to do an all-in-one. We're just going to run a basic terminal, and this lets us Drawterm into the terminal with no password. This might look a little goofy right here, but really this is so that you get quotes, since double quotes produce a single quote in RC when they're inside quotes. In this case, you see, since this is all on a quote with the key, putting the key into factotum, and factotum manages authentication tokens, among other things. So this sets a blank password is essentially the gist of it for user Glenda on our system over DP99K, which is the modern 9front authentication protocol. And it sets it on the default port that Drawterm looks for, even though there's no auth ticket or anything like that. This is sufficient, really. And it just calls that service, this is just an RC script. So that's pretty handy. What this means is, if we cat/net/ I think it's IP self-tab, yeah, there it is. This gives us a general idea of what our network looks like. We see we are 192.168.2.102. This should be the host-only adapter. There are 2 network adapters connected. If we cat/dev/drivers, this gives us all the drivers currently available from the kernel, and we will see that L is ether. Ether is nice for us, though if you do this, we see there's ether 0. However, if we do that, we see there's ether 1. What this really is there is #L0 also, and L1 is the second ether, which is the second network card. By default, these are both mounted in /net, and you see ether 0, and you'll see ether 1. This is where both of our network cards are displayed. One of the cards, which should be ether 0 on the 10.x, is strapped to a NAT in VirtualBox, which gives us our internet access. So if we do this, for example, we actually get a response. And then the secondary adapter, ether 1, which since we are listening on all interfaces, for dlisten and sharefs, this lets us connect from the host-only adapter right here, and due to how this is natted, we don't need to worry about external connections coming in and using our authentication and whatnot. So we rely on ether 1 for connecting from the host, but we need our IP. With a little bit of knowledge about how VirtualBox works and poking around the settings, it's pretty straightforward to figure out that the 192.168 addresses are host-only, usually, and 10.x are natted. So we look for our address, we see that these are the max of ranges, and these look like our actual addresses, and these are the floors. So this one should be our host-only address. If we come over to Unix on the host system, and I made a N folder just for convenience sake, and this has a CPRE 431 folder in it, we can use fuse and 9p fuse, And we should be able to just do this if everything's set up correctly. We see that returns, so there's no authentication, so we don't need to type in a password. And we see the root file system. This is identical if we come in here and look in /root. So we can come in here, we can go to user, we can go to Glenda, we can edit, for example, test.go, add a comment to it. This is just exported over the 9p protocol. Hello world program. Peekaboo from Unix. Cool. Cat test.go, we see that's changed here. If we come over here, we see it's changed over here as well. It's the same file system. So this is really handy. If you want 9p fuse, there is a 9p fuse on GitHub that is standalone. This should work on Linux. I assume it works on Mac. It relies on Fuse. You might be able to get it work in Cygwin. I'm not really sure how exactly that works, but it should work in theory. So you can use at least mount also if you're on Linux. The mount's a bit trickier. It looks something like this. Let me get all this in real quick. 102 and then /mount, and we need to use sudo so we can specify a type. We accepted that. We can /mount. These things might get a little weird though. Yeah, we get like an error. Not really sure what that's about, but when in doubt, just use Fuse. You could also use any 9p client of choice to connect to this, but it's just on 564. But 9p Fuse is what I've used, and it's probably what I recommend using. You can also Drawterm in, and let's get another terminal up here. Since this is just a network address, we can use Drawterm, and the Drawterm we want is, of course, from the 9front project. You can go to 9front.org. And don't see the link immediately, but secretly it is drawterm.9front.org. And there's an exe for Windows, and there's the source code to build on other things. There's supported platforms, works on Mac OS, works on Windows, though it obviously provides the binary for that, and Linux, Unix, BSD, all that good stuff. It's pretty compatible, all things considered. We can use Drawterm. We specify -h in the 9front version. 192.168.2.102. The user is Glenda. We see we're prompted for the auth server, which is the same. And then, oh, it doesn't actually resolve the system. That's pretty great. I guess it's because I didn't escape it. We just put in a blank password in this case. You start Rio if it doesn't start. And there we go. The mouse CTL error was because I have a fixed mouse script that runs, and that's mostly so that there's no mouse acceleration in the VM. I could fix that elsewhere, but that's where it is for right now. And we have a nice Drawterm session. We can full screen this. There's a little less latency with moving the mouse and typing and all of that, which is really nice, and it gives you more screen real estate in general. You come down here, make a nice big window, and read all your favorite PDFs this way. Fossil.pdf, for example. Yeah, and there we go. We can browse our papers this way, get rid of our cat clock, put this in the corner, and get our Acme going over here. And Acme benefits greatly from large amounts of screen real estate. SAM, it matters less, but it's nice all the same. You can close out of this. There's also a text only argument for Drawterm, which is -G. This just gives us a text only interface. We use like ed if we wanted to, like sam-d. Not that it's especially useful in this case, but it does exist. Yeah, that won't work. But if you have Fuse set up, you can of course use Vim from Unix if you absolutely must. But of course you should compile on 9 since Linux binaries won't work. This about covers it. This is everything you really hope for. There's a bunch of oddball stuff hiding out. There's tons of programs on 9, and there's tons of features that I haven't even touched on, like the plumber, where if you have, for example, you do like plum test.go, and we see it pulls up SAM, and it opens our program for us, and this is just really handy. You can do the same thing if we go like /doc. We can do plum, might be able to do libmock.ps, and we get a new page window with it. And this is just fantastically useful in general. You can use this to bounce between programs, or if we already have, for example, if we go into repos, we're going to apply 9, go to C, and we plum rot13.c, see it opens in here. Maybe we sit around editing this, make it a little bit smaller of a window just for convenience. Maybe we have a Drawterm session open with tons of screen real estate, but we want to look at drot13 for reference. We don't really want to open it from here, but oh look, we get it anyways on our SAM because it's listening for the plumber. This is very handy. This is how Acme works. Acme runs through a plumber. If we have Acme open, I think it actually supersedes SAM through the plumber. But overall, you don't need to worry about that too much. Of course, make lets you make. Or mick, I suppose, is more phonetically correct. That about covers it. I hope this has been helpful, and I hope this helps you get through your workflow going in to the project in CPRE 431. And if you're just coming here from elsewhere, I hope it gets you a little bit more familiar with a dev workflow on 9front. Thank you for watching.